Now, stem plot is an alternative way of tallying data, and we're going to draw some in this exercise. First one here shows the taxi fares collected by a taxi driver over one evening. Now, I'm going to do this with a class size of 10. To draw a stem plot, we draw a vertical column, and we put part of the number here and part of the number here. I'm going to put all the numbers from 0 up to 10, not including 10, here. So these are going to be for kind of the noughts. The 10s and up to 20 I'm going to put in this column. This is called the stem. The rest of the number I'm going to put here. So 20s here, 30s, 40s, and have we got any 50s? Yes, I didn't do it quite big enough, but we'll have to squeeze our 50s down here. And so when we write a number here, so for instance I want the first number is 18, I'm going to put an 8 here. So it'll be 1 and the 8 there, that'll represent that 18. The next numbers are 15, and so I'll write a 5 over here. And it goes with this 1, that's the 10 part of the number, with the 5 will make the 15. You need to include a key, so we'll put that in right now so people can interpret it. So the key might be, for instance, that 1/8 equals, and in this case we were talking about taxi fares, that would equal $18. When you're doing this, it's a good idea to work in pencil, and you'll see why in just a minute. We're going to have to rub out some of the work that we've done. So the first number was 18, I'm going to put an 8 there, 15, 12, 6 goes in this group, 14, 19, we're going to have a lot around that mark, I think, 22, 38, 16, 18, 36, 42, 54, 32, 8, 25, 18, 25, 29, 43, 37, 53, 24, and 18. Okay, now I said we were working in pencil for a reason. That's because we're going to have to rub out some of this now. It's important that when I present it, that I should present it all in order. So put the smallest number closest to the stem and extend out. Now this one's already in order, so that's good. But this one I'm going to have to rearrange. I've got to start with my smallest number here, which is this 2, or really it's 12. So I'm going to need that 2 closest to the margin. I'm going to have to rub out and put them all in order. Now I'm just going to pause the tape and do it and fix that up. I'll be back in just a moment. Well, we've done that, and I think you can see how it works out. The data now is all in order of size. That's going to be important to us later when we start calculating statistics with it. The other thing that's important is, notice I've tried to keep it nice and neat, and I've kept my numbers in nice neat columns here. That's useful too, because you can kind of then see which groups have got the highest frequency in them. It's rather like a histogram which has been turned on its side, or a horizontal bar graph, if you like. Let's have a look at a second example here, and it's the forester's tree girth measurements. We had a forester who was measuring the circumference of a whole lot of trees. We've worked with this data before. Let's have a go now. And this one is a little different because it's asking us to group them in with a group size of 5 rather than 10. Now you can still do this with a stem plot. But what we're going to do is we're going to do it like this. The smallest piece of data is around 80, so I'm going to start my stems at 8. But I want this first group just to deal with data from 80 up to, not including 85. So 80 to 84, I suppose, as far as this is concerned. I'm going to have this first group like that, and the second group is going to be for the high 80s, from 85 up to 89. I'm going to call it group 8 star. The next group will be the low 90s, right up to but not including 95. The next group will take 95 and up to 99. I'll call it 9 star. This will be the low 90s, the high 90s, the low 100s, and the high 100s. 100 star will take us from 105 up to 109. Need to include a key, and I just usually take one element off the graph. 102 is going to be on there, so I'll put 10-2 equals 102 centimetres. With these ones with stars, sometimes a good idea to include a star element as well. So let's have the next one, 95, will be in the group, it's the high 90, so it'll be 9 star dash 5 equals 95 centimetres. That'll do for my key. Let's put the different items in here now. The first one's 102. That's one of the low 100s. So I'll put, working in pencil, 102 here like that. 95 is one of the high 90s. There'll be a 5 here. 88 is a high 80. I'll put an 8 here. 96, a high 90. 104, a low 100. I'll put it here. Okay, I'm going to go through and finish this. Then I'm going to erase what I've done so that they can be put in order. I'll be back just to finish this in just a moment. Okay, I'm done on that, and you can see how mine's finished out. I've finished the tallying. I then erased what I'd done and represented them so that they were in increasing order of size as far as the leaves are concerned. Notice how I tried to keep my work in nice neat columns so that I kind of get this histogram effect on the side. In fact, if we look back, we've already done this once, I think. In a previous example, we drew a histogram of the forestry data. That was our original data. Turn it on its side, and this shape here very much reflects the data we've got here. The advantage of the stem and leaf diagram is it's retained all of our original data that was here is still here. Whereas in the previous example we had all our original data here, but once we had grouped it and tallied it here and drawn our histogram, we have now lost the original data. I know that there are two trees between, I know there's two trees which are between 80 and 85 centimetres, but I don't know their exact heights anymore. Over here, I still know there are two trees between 80 and 85, and I know exactly how big they are, 81 centimetres and 83 centimetres.